Good? All right.
I didn't get it.
Morning, guys.
They cleaned out everything the other day? Brought it to me.
Our lesson today is up on student view. It's called the Rule of
I
72.
will call down there this morning.
There is one
How
handout.
much money do you have in there?
Question for the room.
I will call it out.
What do we know about simple interest? Simple interest. What did we talk about yesterday? We talked about savings and the concept of...
Why is this evaluation 86 pages long?
It's called Rule of 72. And our bell work is, let me know what you know about simple interest. Hi.
Isn't it a simple interest?
It's simple.
Okay, but how do you calculate it?
No, I ain't doing this. You're not getting 88 pages from me. I can care less about anything else. 88 freaking pages.
Isn't that what it said? You told me that yesterday.
Oh my God, why?
Andrea,
You can't have this.
you getting the
Is
value?
it set to 11?
No, it's 88 pages.
This right here?
Yeah, stop printing it. No, go to page 88.
Yeah, that's not it.
That's not the right one. I don't know.
What did you say on there?
Yeah, but that's not it.
Critical practice evaluation number 4.
No, I'm not doing 88 pages. I'm not writing that much crap. You can do 88 pages.
You're not being recorded at all right now, Mr. Sticker.
I can edit that. That is all coming out.
So our bell work is the concept of simple interest. Does anybody remember that from yesterday?
Because one.
Do you remember how you calculate simple interest? No? Simple interest calculation? Yeah.
What is on your ears?
Simple. $1,000, 6%. How much interest are you going to earn over a year?
Yeah, it's all nice.
What is on your ears?
Science. Math is no more.
Brandon, any idea? $1,000, 6%, 1 year. Do it.
I do. Oh, so you have no idea.
Nope.
Yeah, what's on your ears?
Literally.
Did you multiply it by 6 or by 0.06?
Am I me? Okay. You made it sound like I wasn't.
So when you do it at 0.06, how much do you get? 60 bucks. Simple interest calculation. Your principal multiplied by the interest rate. Please change the interest rate into a decimal. 6% would be 0.06. 60% would be 0.60, etc., etc. So principal times interest gets you your simple interest calculation. How we doing, guys? How do you calculate simple interest?
Let's see, E equals E times I plus I divided by N times YN.
Not even close.
But that's what it says right here. And that's
Principal multiplied by interest rate equals your simple interest.
Well, I didn't. Where did you? Xander, that's the wrong slide. Are you sure about that?
That's the wrong slide.
Which one is it? Oh, it's this one.
Because we talked about simple interest yesterday, not today.
Oh, my bad. I don't remember it then.
All right, today is day 2 savings. Yesterday was day 1. What we're going to do today, explain compound interest, apply the rule of 72, and evaluate personal finances in order to be successful in today's world. Do you want, you're not doing this, are you too tired? Chance, are you excited about being successful in today's world?
No.
Okay.
Don't get me wrong, I'm coming for Elon Musk's CEO seat.
But
You know what the fix is?
what's this?
So they got a company.
You know what I probably would have gotten on the ACT?
Elon Musk probably got a lot higher than me.
I do not think so. I am not as confident in my abilities as you seem to be.
I feel like.
I'm thinking 18 to 20. Because my high school concepts was 40 years ago. So I would have had to try to remember all that
Yeah.
40 years later. Now, had I studied a bit, maybe I would have performed as well as you. But no, absolutely not. Are we okay with the objectives, guys? Good. Who's that dude?
Albert Einstein.
What's he famous for?
Credited for discovering the mathematical equation for compounding interest, thus the rule of 72.
Is he kind of famous?
Yes, very famous. Blush you, blush you, blush you, blush you. Blush you, blush you. Stop. You're welcome.
So you're right, it's Albert. Has anybody ever heard of Albert's miracle year of 1905?
Nope.
This is not going to go on your worksheet. This is just a little bit of time grinding history about an amazing person called Albert. So in 1905, Albert apparently had the time to come up with 4, actually 5, incredible theories. The first little one was quantum theory of light. And basically what he was doing is he was figuring out why you can take a certain material and put it in the sun and then take it into a dark room and then all of a sudden it'll glow. So he figured that out in 1905. Is that kind of cool? Huh? He also had time that particular year to define the term atom and prove that it actually existed. So that was kind of cool, right? And how did he do that? He just floated things in water. And he said, look, there's a thing called an atom. That was 1905. He also had time that year to come up with a theory of relativity. Laws in physics are the same, even for objects moving at constant relative speed. The speed of light is a constant. So basically what Albert was up to that year was looking for constants in the universe. He was looking for things that are constant. And he said, hey, the relationship between speed of light and relative speed of matter is constant. There's the atom. Things will emit light when they're hit with light. And finally, in the spare time, probably one morning while over breakfast, he came up with a relationship between mass and energy, which came up with that formula. We've seen that before, right? Yeah. So while he was looking for all these constants back in 1905, he also came up with another constant that had to do with mathematics, because the dude was looking for all kinds of constants that year. And he came up with the rule of 72. Now, these previous rules were all kind of complex, right? So today's lesson is probably going to be really complicated, right, with that rule of 72, considering all this quantum theory and emission of light and proving the atom. Not the case. The rule of 72 is super simple. Even though that's kind of a complex formula down there. What Albert figured out is when you're figuring compound interest calculations, you can use the number 72. as a constant and divide it by either an interest rate or a number of years to figure out when an investment will double. That's the entire concept of the Rule of 72. Super easy. But he still figured out that rule in 1905. Question about Albert Einstein. Is he kind of revered in our socio-economic time right now? Do people of America kind of like Albert Einstein? Is there a reasoning behind that? Why do we like Albert Einstein? Well, he was from Germany, though. Well, he lived in Germany in 1905. Exactly. What happened in 1939? Albert Einstein, a Jewish person, immigrated to the United States of America from Germany and became a United States citizen before World War II. Did he help develop the atomic bomb?
Yes.
Actually, he did not physically work on that project. His theories helped develop the atomic bomb, but he did not work on the Manhattan Project. I did not know this until I did my research last night. So, not only was he super smart, not only does his theories make sense, but he also immigrated to the United States of America. He maintained dual citizenship, Swiss and United States, until he passed away in 57. Yes, ma'am. If you know how to do it. So the Rule of 72 answers the following questions. The time it will take an investment or debt to double in value at a given interest rate using compound interest. The Rule of 72 is an easy way for you to estimate the growth of your money. And you simply take your investment rate and divide it into 72.
No,
Yo,
I have a question.
what's up?
So, that's, when you're doing the segment thing,
So you're going to divide 72 by 3,
Kobe,
I got,
and you came up with 24, which is perfect.
are you in?
Yeah, so you divided it by 3 in that calculation, right? Right. When you're doing simple interest calculation directly against the principal, you have to use your decimal. When you're using the Rule of 72, you're going to use whole numbers when you're doing your division. Cool? So what can you do with the Rule of 72? Calculate how many years it'll take an investment to double at a given interest rate, assuming compound interest. Calculate how long it'll take to double a debt if no payments are made. The constant that we need in the Rule of 72 is we're not adding to our investment or we're not paying down our debt. 72 is referring to a number. Albert decided that the number 72, when divided by either the interest rate, will get you the number of years it'll take your investment to double using compound interest. Or when divided by the number of years, will tell you what interest rate you need to have in order for your investment to double in those number of years. So the constant that Albert found that year was that the number 72 was what you divided to get the result you wanted. Everybody following that? So what's the constant that Albert found about compound interest? The number 72. The speed of light, the relationship between matter and energy, and the number 72 is what he found in 1905. So you can calculate how long it'll take your debt to double. You can calculate how many times your money or debt will double in a specific period of time. And you can calculate the interest rate an investment must earn to double within a specific period of time using one simple number, 72. Awesome. It's not that difficult, is it? So, is the rule of 72 a perfect predictor? No, it's only an approximation. However, it gets you so close every time that we have decided to enlist it as a rule. The interest rate must remain constant. Albert was looking for constants, right? The equation does not allow for additional payments to be made. In other words, you can't pay down your debt and use the rule of 72, and you can't add to your investment and use the rule of 72. If you add to your investment, you're going to have to recalculate every time. All the interest is reinvested. That's basically a definition of compound interest, right? All the interest is reinvested. And tax deductions are not included. So at 5% interest, your money takes 72 divided by 5, or 14.4 years to double. To double your money in 10 years, you need an interest rate of 72 divided by 10, or 7.2%. That's the whole concept of the Rule 72. So there's a little grid on your handout. Have most of you finished that already? Yes, you have. How you doing? Yeah. So is the calculation for the Rule 72 very difficult, guys?
Yes.
It is?
Actually, it was.
Let me see yours.
I
Oh, you turned it in? Okay, so we'll scroll a little bit. How about these down here? Scroll. How about that one? Grab that bad boy.
Oh, yeah.
And how about this one down here?
There is no.
There's two questions. Yeah. Yeah.
Let's see how long that guidance trial.
15. No, don't use the percent.
Hold on, it actually got the answer the same way.
Well, go 72 divided by 3.
It's the same thing.
3 divided by 3. He's also showing you
Divide by 3.
that's what you need right there. So when you're doing the Rule of 72, don't change your percentage rate into a decimal.
What I did is somehow I got 2 points. Yep. And that's what I mean, it's super simple. 72 divided by 5 equals 0.4.
So one of the differences between the Rule of 72 and calculating simple interest, we don't modify that interest rate to a decimal. We leave that interest rate as a whole number. So on your grid, you're going to say 72 divided by 3 equals 24. 72 divided by 5 equals 14.4. And then the next two is super easy again. 72 divided by 6 equals, boom, that percent. And 72 divided by 15 equals 4.8%. So that's what the Rule of 72 will do for you. It'll work your way towards the number of years it would take for your investment to double, or work your way back to the interest rate that you would need for your investment to double in that number of years. Cool? Any questions about the Rule of 72?
Wow, I have 210 days.
How can we use the Rule of 72 in our lifetime? Interest rate we might need, right?
Yeah.
Help us make decisions as to which bank to go to,
Or which car to buy.
or in order to get something like an 8% interest rate, is that even feasible in today's society? On an investment? No?
I don't think so.
How about real estate? It's an investment. It's
I feel
feasible.
like you have to have like the most viable location.
Yeah.
What is real estate all about?
Located.
It's about 3 things, right? Location, location, and location.
But that's still like 8% is still
Yeah,
still
it's
pretty
pretty
good.
high.
You better have property in the heart of like LA. Otherwise, 8%.
Wait a second, is property in LA going up or down?
I guess it's good. Still.
And having owned property in San Diego and in Bullhead City at the same time, I can tell you right now that you're never going to see 8% in Bullhead City, Arizona, United States of America. Because what I paid for the properties that I own here in town 30 years ago is probably what I would sell them for today. But what I paid for my property in San Diego 30 years ago is a fraction of what I could sell it for today. So, location, location, location. Also, money market accounts that use investments in stocks could also theoretically give you an 8% on average return, but they could also give you theoretically on average a negative 100% return. Because those involve risk, right? But the higher the risk, the larger possibility for a return like we're talking about, which is 8%. And it's up to you to determine which companies to invest in. For instance, if you had a portfolio that had AT&T, Microsoft, Apple, you know, all of these, would you get between the 6 and the 8% return? You might, over the course of 20 years, or 30 years, or 40 years, because we're talking about a long-term investment. You may actually see an 8%, and you'd actually maybe able to retire with those multiple yachts, and just sail the world. Huh? Well, isn't it? Isn't life like Monopoly? Don't you want to own Broadway and Park Place? As opposed to, what's that one over here? Is it Chase Avenue or?
I don't think anyone's
The one that corner?
Yeah,
Boardwalk.
the Boardwalk and Park Place,
That's the
right?
expensive one. He's talking about the
I'm talking about this one over here.
The brown ones?
yeah, the little
What are these light blue ones over here?
Oh, you're talking about the expensive one.
They do the boardwalk and.
No, dark blue is one.
I'm talking about the light blue ones.
Those are
the ones located in Bullhead City, right?
No, the brown ones are a little bald.
Oh, the brown ones are.
Yeah, the ones like right there. Those little pumped in.
Like $60.
Right.
Like you get $8 a minute. Compared to like 60.
All right, so the constant of the rule of 72 is the number 72.
So basically,
Brandon, you all right?
yeah.
Cool. You all good?
This time I said.
Did you save it first? We've been having an issue on some of the worksheets you guys have turned in the past. Unless you save it onto the hard drive, close it out before you put it in the student view, sometimes it shows up as blank.
Or maybe
Here's your worksheet.
formatting.
If your worksheet shows up as blank, do I give you 10 points or do I give you 0 points?
And
Who do I give you? Chance, I give 0 points because I know he didn't do it.
I did this.
Did you do it?
Yes, I did this.
That's awesome. All right, that's it. Let us know how you can use it in your own words, and then turn it in,
Oh my god, instead of.
and then work on something from a different class or take a nap. I still. Because
bingo.
because you're awesome. So when are you going to have when I grade those things? Like 100, huh? 98?
And there's still one more.
0.7?
Yeah, right.
How are we doing, guys? Where's our lesson for the day? Where's it located? Student view. It's called the Rule of 72. Rule of 72. Bell work. Give me a little bit of information about how you calculate simple interest. Did we talk about that yesterday? Mr. Hart, did we talk about that yesterday? Yeah, we did. What are you doing?
Shoulder that locked in.
Oh, goodbye.
For him to get his teaching license, degree, whatchamacallit. It's part of like his classes, he has to have reporting hours. Something you're supposed to be doing now.
Yes.
Or you.
What do you know about calculating simple interest? Yes, sir. Make an empty spot.
Feels very intelligent, so I can. Oh my god.
Did you finally find student view? Yes, you do. How do you calculate simple interest? How do you do it though? If you had $1,000 and you earn 6% interest, how much money would you earn? What's 1,000 times 6%?
Actually, 0.03.
Yeah. So $60. That's the concept of simple interest. Principal times interest rate. How are we doing? Did you get any more makeup work in the
She hasn't
box?
asked me permission. Wait, hold on. Seven.
What is this computer over here?
She could ask me permission if she wants to take control of this computer.
Oh, this one?
Just say okay.
Oh, there's another one.
SEDELL maker nothing.
Oh, what? Yeah? Do you have any extra drinks? Did you finish first or second in your event? Third?
It was
So can you explain the concept of simple interest? Ms. Mercedes. So that's the definition that we looked at yesterday. So how do you do it? What's the physical nuts and bolts of calculating simple interest? Perfect. Perfect. Yes. So simple interest is you multiply the principal amount, whatever it happens to may be, by the interest rate. Is your computer coming up yet? Finally? We good to move on from the bell work? Simple interest is a calculation of principal times interest rate. For instance, $1,000 times 6% is going to get you $60 over the course of 1 year. How about opening up your handout?
Yeah, you're taking care of my bill.
Save as. Open it up and save as, like you do with all the other works. What's up, Brad? Simple interest is the multiplication of principal times interest rate. Principal. Principal like $1,000, $10,000, $1 million times interest rate. This young lady knows all about $1 million. Million. Oh, you changed again?
Changed again.
Were you here originally? Maddie, are you okay? Or are you sleeping? So we talked about savings accounts yesterday. What type of savings accounts are there? Savings account. What type of savings accounts are there?
Oh, their certificate of, shoot, God.
No, it's not certificate of God.
What is it?
Certificate of deposit. And it's money market account. Thank you for listening yesterday. Regular savings account. What is the difference between a certificate of deposit and a money market account? That is exactly correct. The only thing I would add is on the money market account, it's actually an investment in either real estate or stocks, bonds, things like that. So there's also risk involved in the money market. Cool. All right, today's objectives up on the board. Explain compound interest, apply the rule of 72, evaluate personal finances in order to be successful in today's world. Do you want to be successful in today's world? Yeah? Sweet. What's your plan for after high school? What's your plan for after college? What's your career going to be? It's going to be awesome. You know what's awesome about all those statements you just made? There is actually a plan in there. It really doesn't matter what it is. The fact that you got through photography is awesome. The fact that you have something to shoot for gives you an above average chance of actually graduating high school. The quote, no dream is too small? Why not? No, I like this one. Why try it because you're just going to fail anyway? I know. But the point is you're trying to go after is what? Being what? And you've got a plan. And will that take you to college after high school? Yeah, it will. The fact that you've got a plan of being an accountant puts you in the upper percentile of folks who will graduate high school because you've got something that you're thinking about after today. Nick, are you going to go to college? If we have a plan to, more than likely we will. We've talked about this during goal setting, right? What's the difference between compound interest and simple interest? Simple interest is just simple interest rate times principal, right? Compound interest happens daily, monthly, quarterly, and you calculate that interest, add your profit back into your principal, and then calculate a new interest the very next day. So it's almost an exponential growth as opposed to a simple annual growth. So using compound interest on the same amount of principal, you would actually end up making more in a year than you would under simple interest. The calculations are done much more often. Does that make sense? Same calculation, just done 365 days a year instead of 1 day per year at the end. What's up? Yeah. Absolutely. Perfect. Who's that dude? Is he famous? What did he do?
The first telephone.
He did. What else?
General. How about the first telephone? No, I was kidding.
He built the first telephone? I'll tell you what.
No, he doesn't.
In
Like over here.
this is going off script a little bit.
I can imagine.
So yeah, it's Albert.
Albert?
This has nothing to do with the Rule of 72 except for how amazing this particular year was for Albert Einstein. In 1905, he came up with 5 amazing theories that he proved all in the same year, if you can believe this. They call it the miracle year of 1905 for Albert Einstein. He came up with a little thing called the quantum theory of light. Anybody have a clue as to what that might be? If you take a certain material and you hold it out in the sun, and then take it into a dark room, certain types of material will glow in the dark, right? That's that theory. So he figured that one out in 1905. Not to be outdone, he took a couple of minutes and proved to the world that the atom existed. So that's where the concept of the atom came from in 1905. So while he was working in the same patent office, he came up with a little theory called the theory of relativity, where he decided that all the laws of physics were the same even for objects that are in motion. When you look at some of these things he came up with, he was looking for constants in the universe. He was looking for things that were constant, that you could hang your hat on and say it's always going to be the case. So he came up with one more little theory that year, relationship between mass and energy, which came up with that formula. Have we seen that formula before?
Yes.
So those 4 things he did in 1905. And then after all that was said and done, he was still looking for constant, so he came up with one more rule, and that's the Rule of 72. He applied that to the calculation of numbers and the ability to determine when your investment was going to double. And he found out that the number 72, the whole number 72, was a constant that could be used in a multiplication formula to figure out how many years it would take an investment to double, or what interest rate might have to be used in order to have an investment double in a certain amount of years. That's the formula. We're not going to get into that. All we really want to know is the rule of 72. And the constant of the rule of 72 is the number 72. How can it be used? It can be used to determine the time an investment or a debt will double at a certain interest rate. Estimate the growth of your money. And a simple way to take your interest rate and divide it into 72 to find out the number of years it'll take your investment to double. Cool? What can we do with the rule of 72? Calculate the years it'll take an investment to double. Calculate how long it'll take a debt to double if no payments are made. That's the other constant in the rule of 72. You can't add any money to your investment, and you can't pay down any of your debt if you're going to use the rule of 72 to calculate these percentages in years. And you can also use it to calculate how many times the money or debt will double in a specific period of time. Or if you want to work your way back, you can figure out what interest rate your investment has to earn in order to double in that period of time. Yeah. Good there? Where'd it go? There you go. Enable editing. Oh. Wait. Better?
Yeah, I know. Ben, why did you ask? But like, I feel like in most of my pictures,
I think you can hit the X now.
My work's like really, really well. Like, it looks like I was thinking that.
Are we good, Maddie? No? You done with the matrix already? Same thing. 72 divided by 6 equals boom. That's how easy it is. It's 24. Yeah, because we're going to have to, and that's what I'll tell you in a second, you have to take that interest rate and turn it into a decimal and then multiply with it. Or use 3 and then the percent key. Cool? But in the back way, you use a whole number. Yeah, 14.4. But this is 72 divided by 6 equals your interest rate. 12%.
Because I need 4 braids.
Make sense?
Yeah. And then I end up coming back.
What's up?
What is the rule of 72?
Talking about here? 72 divided by 3 equals what? Got it?
I think it's right here is rule 72. So it's divided by 72.
We good to move on, guys?
It's in your slide.
Well, I want to get to the next slide. Sure. So the rule of 72 is only approximation. It gets you really close to where you need to be. The interest rate needs to remain constant. The equation does not allow for additional payments. Interest earned is reinvested, and tax deductions are not included. The examples. At an interest rate of 5%, your money takes 72 divided by 5, or 14.4 years to double. To double your money in 10 years, you need an interest rate of 72 divided by 10, or 7.2%. What is the constant that Albert found in this rule of 72? What is that constant that he found? You're talking about relativity, that had a constant. He was talking about speed of light, that had a constant. The rule of 72, the constant he found was the number 72. It was just that number 72 somehow allowed you to make the calculation for compound interest.
No, I think I was a little too weird.
So there's your little grid.
Well, maybe
On the first one, it's quite simply 72 divided by 3 equals. Boom. On the next one, it's 72 divided by 5 equals. Boom. Yep. Because the $10,000 makes no difference, right? So 72 divided by 6.4 is 11.25 years, right? Yep. And then how do you do the next one? You got a $1,000 debt, you're not going to make any payments, but then it's charging you 17.8%. How long will it take for that debt to double? 72 divided by yep, equals. In 4 years, you're going to owe $2,000 instead of $1,000, right? So 72 divided by 6 equals boom. 72 divided by 15 equals boom. That's how you fill in that chart.
The second, the third one? I think I look like a boy. I really next year I'm gonna say.
So we're going to do 72 divided by 3 on the first one.
I like to pick this one. Which one did I put?
4 years.
I look like I'm looking back to all the kids.
72 divided by 5 equals what?
And I look for,
72 divided by 6.
You're on your phone
Interest
now.
rate of 12%.
Okay. I'm gonna make it for 2 days.
And 72 divided by 15. This is an interest rate of. That's the entire answer to the rule of 72. That whole number of 72 was found to be some kind of magic silver bullet that got you to either the years it took or the interest rate that you're going to charge. Now on that question right there, we made an investment of $10,000. It's going to return 6.4%. How many years will it take to double? Does the $10,000 make any difference to the calculation? Okay. It's not even in the ballpark. It's 72 divided by 6.4, right? That's how many years it's going to take to double. 5 years.
Do you know how hard that is?
So the next one, how long is it going to take for your debt to double? Done. 72 divided by 7. Good? Hi! Yeah, made an investment of $10,000. It's going to pay 6.4%. How long will it take for the investment to double? Does the $10,000 make any difference? It's not even part of the calculation. It's 72 divided by 6.4. The amount of money makes no difference. It's just that number, 72. Cool? You got your grid filled out? $10,000 at 6.4%. How long will it take to double?
4
How are you
years.
going to do it? Does the $10,000 even enter the picture as part of the calculation? What is? 72 divided by 6.4, right? That's how many years? 11.25 years. That's it. Now you owe a debt of 1,000. You're not making any payments, but they're charging you 17.8 interest. How long is it going to take for you to owe $2,000? What's our magic number? 17.8. In 4 years, if you don't make any payments, you're going to owe $2,000 instead of $1,000. 72 divided by 17.8.
So when you get a big number like that, you would just round to the nearest one?
Make sense? Yes, you do. How can you use the rule of 72 in your future? You can get all those weird calculations of compound interest out of your mind and say, you know what, I got $100,000 in the bank, I'm making 4%. It'll be $200,000 when? You got $100,000 in the bank, you're making 4%. When will you have $200,000? 72 divided by 4. 24 years, 60, 80, close to the 18 years. You really should. You should write it over there, your answer. It should be Albert. It's fine. So, is Albert Einstein fairly popular in the United States of America?
Yes.
Why?
Because he's very intelligent.
Where was he born? Germany. When did he live in Germany? In 1905 for sure, right? Because we saw that miracle year, right? So why is he so popular in the United States? Didn't we fight 2 world wars against Germany? Wouldn't we be a little bit biased? Go ahead. You know what it's because of? Albert Einstein was a Jewish man living in Germany up until 1939, when he immigrated to the United States of America and became a United States citizen. Here we are. Not only was he super intelligent as far as relativity and great theories, he also wanted to live in the greatest country in the world. Boom! Way to go, Albert. All right, save it. Okay, so it's got all the info on it. It's fine. It'll look fine to me. So we save our worksheets. Then we drop them in the Dropbox. That way they won't be blank. Yeah. Yeah. We're going to give you a pen. Do I grade really hard? The only time I grade hard is when I see things under that are really kind of snarky. I don't know you guys putting in snarky recently. All right, save them off, put them in the box. Thank you.